Okay, hey everybody. As promised, I said I would work out a few more problems on finding the area of a segment in a circle. All right, so here is my first problem. Remember, at any time you want, please pause the video so you can write down the picture and write out the formula. And then if you want to stop right there or pause it again and work it out, try to work it out and get an answer. And then then you can hit play, watch me work it out, and then you can compare the answers. All right, let's get started. I got this circle here. A couple things I'm going to notice from the circle before I even get started. I got the radius of 6 centimeters. I can see that because of that right there. I have a central angle of 120 degrees because I can see that that is right there. All right, so those are really the only things I need when I'm finding the area of this segment. Okay, so the formula, remember, is going to be the measure of the arc in degrees over 360 times pi r squared. Now remember what that does. That gives me the area of the entire sector. So that's including this triangle part right here. That's including that triangle part. Then I'm going to subtract that triangle part, and I told you the formula for finding that area is 1/2 r squared sine of theta. All right. And remember, these are the things that we have to fill in. All right. We're going to fill in the measure of the arc in degrees. We're going to fill in the radius. We're going to fill in this radius, and we're going to fill in the sine of theta. I'm sorry, the central angle to theta. Okay. All right. Pause it here if you want, and I will continue. All right. So I need to find the measure of this arc. Remember the measure of this arc in degrees. That is the same as the central angle. So that's 120 degrees over 360 times pi r squared, and in this case my radius was 6, so 6 squared. Now remember this in the notes that I did yesterday, I told you go to the calculator and do this, right? Okay, we're going to use 3.14 for pi, right? 3.14 for pi. Okay, so on my calculator, I have 120 divided by 360, and then I hit the enter button because that'll give me that. I don't know if you noticed down here in the I wish I can write on this, but down at the bottom next to the point, there's ANS. That stands for the answer. So I'm actually going to hit that, pulls the answer down, times 3.14, because that's what I said I was going to use for pi. Hit enter. I'm going to hit the answer button again because it's going to pull that 1.04666667 down for me. And I'm going to hit times. And my radius for this problem, my radius was 6. So 6 squared. So there's my answer, 37.68. So this first part is 37.68. All right, now I'm going to subtract 1/2 the radius again, which was 6 squared, times sine of 120 degrees. All right, and again, I'm now moving to the calculator, and I'm going to type this in just as it is in the calculator. All right, so 1/2, so I'm going to do 1 divided by 2. Let me clear all that. So 1 divided by 2, enter, times the radius squared, which was 66, whoops, the answer times 6 squared gives me 18. Then I hit the answer button again, and then that times sine of 120 degrees. Enter. And there's my answer, 15.59. 15.59. All right, so this first part, the 37.68, that's the area of the entire sector, right? The entire sector. The 15.59, that's the area of this triangle. So if I subtract the area of the triangle, that's going to leave me with the area of the segment. So, sorry, 37.68, 37.68 minus the answer, which we just put, 22.09. Centimeters squared. Because remember, when we're finding area, area will always be units squared. All right. Let's try another one. Ooh, there we go. Okay. So the measure of the arc over 360 pi r squared minus 1/2 r squared sine of theta. So that is the entire formula. Remember, the things you only have to plug in are the measure of the arc, the radius, and theta. The arc, the radius, and theta. Okay. So since my central angle is 60 degrees, my arc will be 60 degrees. And my radius in this problem is 3. So I like to go and do this problem in the calculator. So I'm going to move over to my Desmos calculator. Okay, so we have 60 divided by 360. Hit the enter button, it gives me that. I'm going to hit the answer button, so it brings down that answer, times the 3.14, that's the pi. Hit enter, that moves it, so it gives me that answer, 0.52333. So I'm going to use that answer again, times my radius, which my radius was 3 squared, 4.71. So this first answer is 4.71. Now remember what that is. That is this entire sector. That's this entire thing, right? So I now have to subtract the area of the triangle. And I subtract the area of the triangle, I'll be left with just that green part. Okay. All right. So I'm going to minus 1/2 3 squared sine of 60. Okay, in the calculator. Here we go. 1 divided by 2, enter, it gives me 0.5. I'm going to hit the answer, so it brings down the 0.5 for me, times the radius, which was 3 squared. Enter, that gives me 4.5. I'm going to pull that answer down, 4.5 times the sine of 60 degrees. Enter. And it looks like we get 3.90. This is 3.90. All right, now all I have to do is do the 4.71 minus the 3.90. 4.71 minus the 3.90. And it looks like 0.81. So my answer, 0.81 units, in this case, was inches squared. 0.81 inches squared. All right, well, I hope you enjoyed those two practice problems to show you again how to do them. I highly encourage you to possibly start this all over, the video all over, and work them out again yourself to see if you can get better at it. If you need to, please do it a couple more times, and then tomorrow we'll have an assignment. All right. I hope everybody is doing well, and I hope to see you all soon.